Then the optimal configuration is actually a combination of the two, and this is where that yellow block comes into play here. When I say I can take advantage of the incredible sequential write speed of the normal hard drive, and at the same time advantage of the solid-state drive read speed by dividing the files into two. I put the transaction log on the hard drive and the rest of the database on the solid-state drive. And then what happens is, now this is possible. I can actually write the extended data to the transaction log instead of to the data log. And I can do this because both types of logs have the same format. And when I do this, then I'm taking full advantage of the sequential write speed of the hard drive, and without any modification to PBXT, I allow the compactor and writer background threads to transfer the data to the solid-state drive in the background. And then I'm reading mostly after that from the solid-state drive. So we change gears now a little bit and have a look at as I said, where we're going with PBXT. How will HA actually work at the engine level with PBXT? It involves a kind of ramp up. I've called it a ramp up. I've got a master system here, the slave system there, and this ramp up has 3 stages. The first phase is the transfer of an MVCC snapshot. So I mark my position in the log and transfer a consistent snapshot to the slave over the cloud in the middle here. So I've got 2 threads involved here, 2 more background threads. The one is the master thread, the other is the slave thread, obviously one sending, the other receiving. Now the master thread is also following on in the transaction log. Okay, so that's the phase 2. First of all, when that's complete, then we have the roll forward phase where we're using asynchronous replication to catch up. And it transfers the entries that are made in the data log to the slave system. And once the systems are almost synchronized, it can switch to synchronous replication, which involves a feedback. And now you've got, at this point, a real HA system. So it's for the synchronous replication to work, what it does is it asynchronous replication will normally wait for a transaction to commit before it transports it to the slave. But in synchronous mode, it transports the records as they're written, and in the optimistic assumption that most transactions are going to be committed. But if a rollback does occur, then that's not a problem, because a rollback record is written to the master log, and that would be also transported over to the slave, and the slave can do a rollback just like the master did. And then in synchronous replication, so in synchronous replication mode, the slave is sending feedback, real-time feedback about whether it's done committing. But this is not a true two-phase commit. That's not required for synchronous replication. But here comes a kind of funny thing. Once it's gone into synchronous mode, it doesn't need to flush the log anymore, because this system as a whole is durable. What happens is, if assuming that they don't crash simultaneously, okay? Assuming that they don't crash simultaneously, the whole system is durable. What happens if one system crashes, then the synchronous replication channel is immediately cut, and the remaining server flushes to disk and reverts to syncing the log. And the next step after this would be bidirectional replication, and that's not planned for the first phase, but it's opens a number of very interesting possibilities for the future. Yeah.
Can you enable the log flushing? Because if you lose power to the colo, they'll both go offline.
Yeah, sure. True. If the power fails, then they'll both go offline. Yes.
This replication, what's the latency between two data centers?
Yeah, this system would be affected by the latency between two data centers, and I wouldn't recommend synchronous replication between data centers. You need to be closely coupled. This is a localized system for synchronous replication to make sense. I'd use asynchronous replication in the case of such remote systems. And if you're doing bidirectional, you need conflict resolution. That's something else. So the advantages of this solution, if you've been reading ahead maybe, well, first of all, it's at the engine level. It doesn't involve the binary log, and the binary log has certain inefficiencies in that, of course, you're writing the data once again, and transaction commit has to be synchronized with the binary log. The system also allows a rapid failover. Obviously, if they're synchronous, then it's up to date. There's no catching up to do. Asynchronous replication always introduces the possibility of data loss. That's unavoidable. Right, obviously the slave is online all the time, so the hardware that you're using is not dead. It can be used for reading, and reading without worrying about the problem of latency, replication latency, and for backup. And it can also be used for backup. And this system is scalable, so scalable by adding additional replication processes. I can replicate to multiple slaves. A master-master configuration is also conceivable where you're only writing to one master. And I want to talk about the possibilities of bidirectional replication and how the design of PBXT actually allows us to quite possibly scale writes in such a configuration. But I'll get to that in a minute. We first look at an alternative configuration, an alternative HA configuration for PBXT, which is a bit more efficient than the one I've just described. The one I just described, I had to actually transport the data that was stored in the data logs as well to the slave system. And here I'm actually saving that step. What we have here is a shared file system, and we're putting the data logs on the shared file system. So both the master system and the slave system have access to this shared file system, and this shared file system has HA capabilities of its own. For example, this could be on DRDB, or maybe, or whatever, if the SAN has possibilities. So let's look at an insert or update. What's happening here is the usual split. The data log, the extended data is going to the data log, the other data is going to the transaction log, and what's being replicated then is only this part of the record, because the slave system already has access to the data that's been written to the data log.
So only the transaction log has to be replicated?
So only the transaction log has to be replicated, and not the data logs. So that's quite a saving.
And you can configure how large and small the portion of the data that goes into the transaction log is. So
and I can configure, Baron's saying, yeah, I can also configure this, and actually that's the subject of the next slide. I can configure the size of what he's saying is I can configure the size of these things by adjusting how my table, the record structure on table creation.